I'm going to come down to the now, and it says we're recording. So with that, if there's no other questions, I'd actually like to turn it over to our guest tonight, Jeff Williams. He is, and please make sure I'm correct in saying this, you are the one of the original co-founders of OWASP Global. Am I to say that correct, Jeff?
You're on mute.
Yeah, that's right. Sorry. I am, yeah, I'm one of the original OWASP members, and then I took over as the first global chair of OWASP, and I ran it for 10 years.
So I hope I did the introduction correct on that. So I apologize if I didn't, but it is a special treat to have you here tonight, and I appreciate you taking the time to come speak with us. For those of you who don't know, Jeff has actually spoke at the Cybersecurity Symposium in Charlotte a couple of years ago. We were just talking about that before we got started. He was the keynote speaker there. Me and him got to hang out for a little bit. I got this great picture of me and him. Oh Lord, let me find it. Oh, oh Lord, this is gonna be embarrassing for me because like I sent it. Who did I send this to? Oh, where is it? Oh Lord. Oh Lord, where is it? Just know it's a really great picture of me sitting there, absolutely not knowing what to do with my hands. And Jeff's got the great going, like, there we go, man. So this is what you do. He's got the finger pistols going. It is an absolutely fantastic picture. So with that, I would like to turn it over to Jeff. Jeff, thank you very much for being with us tonight. The floor is yours, my friend.
Thank you so much. Thanks for having me. It's always fun to come to Charlotte. I love that area. I got a bunch of friends down there. So I just want to give you a little background. Like I am really excited about this talk. I've spent over 20 years in application security. I've done almost every role you can imagine in the application security world. I helped start OWASP, as we mentioned. If you've used things like WebGoat or the OWASP Top 10 or attended a chapter meeting, you've seen some of my stuff. And I also started a consulting company. I've worked with hundreds of huge companies on helping to build their AppSec programs, and learned a lot doing that kind of work. I've done a lot of pen testing and code review. I've found tens of thousands of vulnerabilities. I'll share some thoughts on that side of things and how you can get started in this space. And most recently, I started a company called Contrast Security. And we take a little bit of different approach towards automating the challenges of application security from, not just testing, but also analyzing libraries and protection in runtime and serverless. We use instrumentation to do a lot of those things, which has a number of really key advantages over traditional approach to AppSec, which is more like scanning with SAST and DAST and web app firewalls, kind of the outside-in way of thinking. So this talk is really about applying this idea of instrumentation to the application security problem. And it's something I've spent the last 7 or 8 years focused on entirely. I'm still just as excited about it as the day when I first invented it with Arshan. I'm going to share a little bit about how this approach works and how it's different and some of the advantages. Please jump in if you got questions, throw them in the chat. I'll put the chat window up here so I can see it. I'm happy to try to answer them as we go here. We're going to do some demos. So this is going to move fast. So, please, if you do have questions, chuck them in there. And again, thanks for coming. All right, so let's get started. So let me share my screen here. Let's see, that should do it. Okay, so yep, here's the talk. That's me. And I always start my talks with a little bit of reality check. And this is hopefully the only doom and gloom kind of slide in the talk here, but we're not doing that well at application security. I'm really proud of what OWASP has been able to accomplish. Like, I love some of the projects there. I think, OWASP as an organization has grown and matured. The most recent top 10 is great. If you haven't checked it out, you should. But at the same time, we haven't really changed the world. Like, the number of vulnerabilities in the typical application is about the same as it was 20 years ago when I wrote the first OWASP top 10, 19 years ago. And what's really disheartening is it's the same vulnerabilities for the most part. I kind of thought when we wrote the first top 10 that we'd be raising the bar over time, but that's not what happened. I thought we would have eliminated things like SQL injection and XSS and things like that, but we haven't. The average AppSec the average app project has like 30 vulnerabilities, several high vulnerabilities and critical vulnerabilities, and they're open source. That's something that we added to the OWASP top 10 in 2013. I spearheaded that. I actually got a lot of rough feedback on that at the time, but history has proven me right, I think. And we're just not really very good at writing secure code yet. So I'm pushing really hard to try to change that. And I think things like the new executive order and the focus on transparency and visibility with things like SBOMs and security labels on software, really interesting, powerful ways to try to affect the software market that OWASP has got to get behind. I did a talk at the OWASP 20th anniversary event a couple of weeks ago where I pushed OWASP really hard to take on the market and not just be a training and conferences kind of organization. So look, that's the vulnerability side of things. We introduce a lot of vulnerabilities into our code. We are also under attack. Contrast monitors tens of thousands of applications continuously and APIs. And really, Contrast is a selection of people who care enough about security to pay for a product like Contrast. So we should be seeing the best apps out there, but our average applications are attacked over 13,000 times a month. There were no applications that didn't get attacked at least once. And what's interesting here is 99% of vulnerabilities don't connect with their intended vulnerability. So lots of SQL injection attacks coming in, lots of XSS, command injection, XXE, expression language injection, all that. But most of them are just harmless probes. They don't go anywhere near SQL queries and expressions and XML parsers and so on. So it's important that we understand that there's a lot of people out there scanning for stuff, and we're really protected by luck in a lot of cases. Okay, so if you want more on that, we put out a really cool report, the AppSec Observability Report, tons of charts and graphs and details in there that I think are really powerful. Okay, so I mentioned the word instrumentation a few minutes ago, and I want to explain what that is. And so I'm going to use this basketball as the way to explain it. This is the 9450. 9450, by the way, is the dimensions 94 by 50 of a full-size basketball court. This is an instrumented basketball, and it measures a variety of things about your game. It measures the ball rotation, the speed of your dribble, makes and misses, a whole bunch of other stuff. And all you do is play with it. You just play your normal way. It gives you some drills, you do, practice drills and so on. And the ball analyzes your game, gives you a dashboard, tells you where you need to work on stuff, gives you drills to fix it. It's amazing. I've been playing basketball for over 40 years, and I played with this thing for a couple hours, and it told me I was shooting too flat. So I made an adjustment. It changed my game. It improved my game, no question. And this, if you zoom out from this a little bit and think about how this changes the relationship between player and coach. There's a ton of people who want to learn to play basketball and are out there playing it that aren't getting good coaching. You go to any gym and see any kid under the age of 24, and they all think they're Steph Curry shooting from half court because they're not getting good coaching. This ball with instrumentation can help change that relationship, change the players into folks that can mostly train themselves, and it changes the coaches. They can be monitoring dashboards, getting high-level information, focusing on problem areas, and not be involved in the day-to-day, drills and so on. It works in healthcare too. Probably a lot of you are wearing, Fitbit and smartwatches and carrying around iPhones. Those things instrument you, and they probably know that you're sick before you do. It changes the relationship between doctor and patient. And I'm not going to run this analogy into the ground, but think about the relationship that we have between security people and development teams. It's mostly awful. In many organizations, they're siloed. The security folks are throwing work over the wall onto the development team, or forcing the development team to use tools that they're not set up to use. That's kind of the negative side of shifting left. I call it shitting left. If you just give security tools to developers, it's not a good match. We need different security tools for development. So we need to change how that relationship works. We need security experts to get out of the critical path, be coaches and toolsmiths, and we need to empower development teams to do most of the heavy lifting around application security, but not additional work. We need to figure out a way to make that part of their normal work. We'll talk a little bit more about that, but this is the big picture of what instrumentation can do. Now, the good news is instrumenting software is easy. Almost every language environment has a built-in technology that allows you to instrument the code. And people have been instrumenting software for 15 years. They do it for logging, they do it for debugging, they do it for performance. In fact, this is exactly how tools like New Relic and App Dynamics work. They instrument the code and then watch it run. They measure how long database queries take, and they give you observability into that code. Well, we can instrument the code for security too. Here's how this is a diagram that I made of the Java instrumentation API. And all you do is you implement an agent that has a transformer in it. And as the code on disk loads into memory, and every language has some process that does that, we get an opportunity to add sensors to that code. Really, it's just weaving in some static method calls, some snapshots of what's going on in the code. And then the code that actually runs has this instrumentation in it. This instrumented code is exactly the same as if you'd written those sensors into the source code yourself. But let's face it, we're not going to go instrument all the libraries and frameworks and custom code and app servers and Java EE implementations and the JVM itself. We're not going to go instrument all that stuff for security in advance. This is runtime instrumentation, where we're actually weaving these sensors in as the code loads, so that we can take any application, instrument it for security, and then run an instrumented version of our application. And we'll talk about performance impacts of doing that a little bit, but the TLDR here is the impact on performance is negligible. In some cases, impossible to measure. It's so fast. So let's take a look at how this ends up looking from an outside view. Imagine you're a pen tester, and you have to go in and test applications. Someone once described pen testing, and I did a lot of pen testing over the years. Someone once told me it was like trying to fix a problem in the water heater by staring up the shower head. And it's a little like that, because you just have no insight into what's going on inside the thing that you're testing. So with instrumentation, I want you to imagine that you're a pen tester over here, but you've got a buddy inside the application, inside critical calls like SQL queries and XML parsers and expression language evaluation engines and HTTP requests. You've got a buddy in there watching all that, and they can tell you, hey, here's what happened when you sent in that malicious query, or here's what happened to that data that you sent in. I watched it flow through the app, and look, that one, it went to an API on the back end. This other one, it went into a database. It can completely spy on what's going on. Anything you want to know about what's going on inside the running application, instrumentation can tell you. Let me say that again. Anything you want to know about what's going on inside a running application, instrumentation can tell you. And so it's a really powerful technique. And I'm going to teach you how to do it yourself so that you can start instrumenting applications and gathering really cool information. Okay. One point I wanted to make on this slide is about this runtime reality. There may be some people out there that think that, scanning a source code repo is the best way to find vulnerabilities, but it's not. Source code repos don't have anywhere near all the information that you need in order to find stuff. A lot of the information you need is in libraries that come from the app server, they come from the platform, they come from the environment. There's data that you don't have in the source code repo that you need in order to understand what's going on in the application. You can't see any of the data flows or control flows really in the source code repo. It's really the wrong place to look for most vulnerabilities. If you want to really see vulnerabilities accurately, you need to look inside the fully assembled application as it's running, and then vulnerabilities are obvious. They're easy to see and super accurate. So let's talk about why that is. So I want to use some examples using the Java Observability Toolkit. This is an open source project that I'm a part of. It's completely free and open, and it allows you to write instrumentation sensors without coding anything. So instrumentation is a little tricky to write. You got to write an agent, you got to instrument the bytecode, it's got to do all these things. So I made a version, a tool that allows you to instrument code with just a YAML file with some simple syntax that you can easily put together. You can write your own sensors, you can add them to applications really easily and get telemetry out of running applications without having to do any coding. I really do think of it, this diagram sort of shows like a multimeter that you would use to test a circuit board. It really is a little bit like that. We're going to throw some sensors into the application, we're going to run it, and then we're going to measure stuff directly from within the running application. So let me get to my demo here. And I think it'll be easier to demo this. So the first thing that you would do to get started with Jot and to start measuring stuff is go download a copy of the Jot library. So you can do that. This is the Jot homepage. It's a GitHub project. You should be able to find it pretty easily. Go to the releases and just download jot.jar, the actual engine. That's it. We'll keep that. And
so, Jeff, I have a
yeah,
question.
go ahead.
And so so with this, we'd have to have a running Java instance, I guess, in the background. Or let me ask that a different way. What are the prerequisites to run this outside of just downloading the jar file?
Yeah, there's really, I mean, you just really need a Java application of any kind.
Okay.
And I'm going to show you how to connect the agent to the Java application right now.
Perfect. Okay, thank you.
Okay, so I'm in a directory here. I'm going to use a web example, but Jot is not tied to web applications. You can measure anything that runs on Java. And look, I'm looking for people to help me build a .NET Observability Toolkit and a Python Observability Toolkit and so on. You got to start somewhere. But I think you'll see the power here. So right now I have this Jot jar file, and I've got a few Jot YAML files here that we're going to use. I'm going to show you the first one is a untrusted SQL query one. This is like the simplest Jot that you can imagine. And here's how it looks. Oh, it's in my Jots directory. So this is a Jot, and I'll walk you through this. So we'll give this sensor a name. This one's called get unsafe queries. And that's all it does, is it identifies unparameterized database queries. This is not exactly the same thing as database queries that are susceptible to SQL injection, but you may have a policy, you probably should have a policy that says you really want to use prepared statements and not these unsafe SQL syntaxes. So this is a quick way to find these across one app or hundreds of applications. You make a sensor like this. You define the methods that you're interested in. This is where you're putting your sensors into the code. And we're going to exclude prepared statement because this one's safe. It's a sub, we have to do that because it's a subclass of statement. And the way this is, this jot will actually instrument anything that implements these APIs. So any JDBC driver from MySQL or Oracle or whatever will all implement this API, and we'll instrument them all with a single jot. And then we're going to capture the arguments to this method. This captures is like, what data do we want to extract from the running application? And this syntax is actually really powerful. This is a Spring expression. And I'll show you how later, how you can use this to access, not just parameters to methods, but you can access, other classes, you can call methods, and you can actually really pull some interesting data out of applications. So now I've got my jot jar file, and I've got my unsafe SQL jot, and we'll just put them together. So we're going to just use this syntax right here. We're going to define an environment variable called Java tool options. This tells Java, use this Java agent, and we're going to use it with this this jot file, except that I want to make this the one we just looked at, unsafe SQL.jot. Okay, so now we just run this application the normal way. So I'm just, in this case, it's a web application called Ticketbook, and I'm just starting it up the way I would normally start this up. If you actually look at the log here, you'll see as this app started up, you'll see that we installed some sensors. This is Jot adding those sensors, and it adds virtually no time to start up. So now we're up and running here with an instrumented application. And all you do to trigger those sensors is just use this application normally. So I'm just, I don't have to hack this application. I'm just putting in normal data here, clicking on some buttons, browsing around. It's, let's do a Wasp, Charlotte, so you can get a sense. Like, the sensors are in the code, and every time we hit a query, we get an unsafe query, we get a nice trace of it. This shows me the rule that got violated, the exact method and the exact line of code, and the full query. There's, OWASP Charlotte that I just typed in. So all you have to do is use your application for a little while, maybe run your automated test suite or whatever, and this tool, Jot, with this Jot file, will identify all the unsafe queries in your application. So it's like a really powerful way to gather data that would be tough to find in any other way. Now, this one you could probably do with static. It wouldn't be quite as useful, but you wouldn't see the data flow. You wouldn't have like clues as to whether this was susceptible to SQL injection. But this is like the simplest possible thing you can do with this. So I just want to pause here and see if there's any questions on how this worked and what we did, because we're about to get a lot more complicated.
So, I mean, and I'm as you're talking about this, I'm looking through the GitHub repo as well, because I'm sitting there going, this is some good, this is some cool, this is some sexy stuff right here.
Just hold on. I just want to make sure we go like baby steps first here, because actually instrumentation is not a normal thing. Like, most developers don't encounter this. It's just, you're actually writing code to infiltrate another piece of code and watch it run. And so it's just a little bit of indirection that's, it takes people a little minute to get their head around. Let's do another example. So let me see what's next. I'm going to go to my slides here real quick. So I'm going to send these slides out so that you'll have a picture of each of these examples if you want to go back to it. Oh yeah, I like the encryption one. This is interesting. If you want to know what encryption is used anywhere in an application, we can write a sensor that looks like a Jot that looks like this. This one, it just goes into the cipher.getInstance method, and it captures the first parameter to that, which is the name of the cipher. Then we're going to do something a little different. This time, we're going to build a table of the ciphers that are used in this application. And so you can see down here, as we use the application normally, you can see this application has a ton of different kinds of encryption in it. And this is not as rare as you'd think. Everyone's like, oh, we need to stamp out, MD5 and SHA-1, and we need to get rid of single DES, and it's never going to happen. those algorithms are wired into everywhere. But it's really interesting to see where. And this is what observability is all about. We can see things inside applications that would be very difficult to find any other way. Most of this encryption stuff in most applications is kind of deep inside libraries. In this case, you can see 3 of these are deep inside this SSL engine that's built into into the JVM, into Sun libraries. This isn't something a developer wrote. This is something inside, deep in the platform. And you can see this is using, AES. It's not bad. It's using Cypher block chaining. It's not great, but like, this is what you need. This is the visibility that you need. And before we move on here, I just want to take a second and point out this Spring expression thing. In this case, the capture is the first parameter, P0. You can put P0, P1, P2, you can do all the parameters. You can, that's when you type in args. You can also get the object. So in this case, the cipher itself. And you can get the return type if it's a method that has a return. In this case, this is going to return an instance of Cypher. So you could get that and make calls on it directly. So you can branch out from these things and snoop more information out of applications. So in the interest of time, I'm not going to run this one. It runs exactly the same as the last one. You just use the application and this table dumps out. This next example, I think, is really powerful. This is about access control. And I'll demo this one because I think this is really neat stuff. So I used to spend a lot of time pen testing access control. It's really interesting and fun. It's hard though. Even if you have the source code, figuring out, does every route in every app have the right checks for every user that's logged in to make sure that they're not able to do something they shouldn't be allowed to do. It's complicated. Access control checks are often spread all over within an application, some at the function level, some at the data level. It gets really complicated to understand what's going on. So I used to spend weeks and I found some major flaws in access control, being able to access things as a normal user that only admins should be able to do, invoking functionality on other users' accounts, all kinds of things like that. So we'll do an access control example here, and I want to show you the jot file here. So let me walk through this one. This has 3 sensors and 2 reports. So you see you can pile up these sensors in a single jot. And you can also run multiple jot files at one time if you want. The 3 sensors are interesting. The first one gets the current route. It just says, hey, give me in the service method, we're going to get the first parameter, which is the HTTP servlet request. And we're going to call get request URI on that. So now we know the URI that this request came in on. Then we're going to get the user. So we're going to do the same thing. We're going to get the HTTP servlet request. We're going to call get remote user on it. And we'll see which user is logged in. So now I know the route and the user. And those 2 things go into this first report. It's just a test coverage matrix. It shows you all the URLs and shows you which users have tested that, which roles have tested that, that particular URL. So that's useful. If you're doing a pen test, it's a great way to make sure you get coverage. But then this last sensor is also really interesting. This is a sensor that we put into is user in role, which is an access control test built into Java EE. It says, is the currently logged in user in an admin role or in a guest role or in a manager role or whatever. And so this will, we can put a sensor in that and we can flag everywhere in the application that access control checks are done. And we're going to capture the first parameter, which is the name of the role. We're going to build a table out of that that says, hey, build me an access control matrix based on the routes and the roles. And you'll see what that looks like in just a second. So again, I'm going to enable this. I'm just going to use this jot. I'm going to rerun my application. And you can run all these jots at the same time, by the way. I just like, it's easier to separate it out a little bit for demo purposes. But here we go. So our application's started up and I can browse around it. I'm just going to click on a few links here and you'll see right away, Jot is already building the test coverage matrix. As a guest, I just hit these 4 URLs. And as you go down the page, you can see we're going to add a bunch to those. I'm just clicking on links. I'm not entering any data or anything. You're just seeing, look, I've visited these pages. And as you test stuff, you can, run more and increase your coverage here a little bit. So now let's look at these access pages. These have access control tests in them. And so when I click on the first one here, you can see I accessed page A, and in that page, there's a test to see if I'm in role A. So I get a little X in that window. That's kind of neat. Seems like page A probably has should have a test for role A. Let me see, I'll click on B, C, D, and E here. And you'll see how the test matrix comes out. It says, hey, page B requires role B. Page C requires role C here. Page D is missing. That means there's no access control checks in page D. But if I look up here, I can see I definitely accessed it. So there's probably an access control check missing in that page. And if I tried to access it as some other role, I could probably do it. In page E here, there's 3 different access control checks. And sometimes that's fine. Some pages have both normal user functionality as well as special functionality that executes if you're in an administrative role. That's fine. So notice that I'm not concluding that there are any vulnerabilities here for sure. You need an expert to do that. And that's why some people call access control problems business logic. They're really not. They're really just a security control that's not observable. But here we can make it observable. We can reverse engineer the access control matrix from the application itself and then give it to somebody on the project. They can look at it very quickly and go, oh yeah, this, there should be a check here. This shouldn't be accessed by role D and so on. Those are the vulnerabilities. So we turned something that was really difficult to do for an expert into something that anybody on the project can do by making it observable. See how instrumentation is unlocking security from what's buried inside the code and buried inside the running application? Any thoughts on that?
That's so I'm looking at this and I've got like 2 or 3 things in the back of my head right now. There's like 2 or 3 engagements right now that I've got in the back of my head that this is definitely going to add a immense amount of value to. So I'm man. The wheels of time are turning in old JJ's head right now. So
Yeah,
it's
excited
just
to try it out.
I'm sorry, say that again.
You said you wanted to know what we thought. I said, I'm excited to try this out. It looks awesome.
Yeah, it's really fun. I mean, I'm totally addicted to this. After doing this for 7 or 8 years now, I'm still totally addicted to it because it's so much better than pen testing in the blind. Of course, you can build automated rules on top of instrumentation, and that's kind of what Contrast is, my company's product. That's a category of tool called IAST, and we'll talk about that in just a second. But you can build IAST yourself with a tool like Jot. And it makes pen testing so much easier and more fun. I'll keep going here so you can see some more. This test matrix stuff, by the way, is interesting. This app has a way of switching users really easily. Rather than logging out and logging back in, I just made a little button that switches me into being user A. And now when I click on these pages, you can see I just accessed these access pages as user A. And if I click on, I'll user B and I'll just click on, I'll switch to user B and click on page B, click on C for C, click on D for D, and for E, I'll click on all these pages. I'm sorry, I'll switch to E and click on all these pages. And you can get a sense like, wow, I can really see where the gaps in my testing are, right? Like, it looks like mostly I tested all the right things, but if if there's an access control check in user D, for user D here in page A, I want to make sure I hit that. Like this really shows you, that you kind of need to access every page as every user in order to test whether it's really, really has any vulnerabilities. So this is, I mean, if you really looked at the access control test coverage that people are getting when they're running scanners and when they're using, pen testing, I think you'd be really surprised at the coverage that you get is not nearly what you think it is.
So something like this, I mean, I'm looking at thinking that, this takes, you mentioned it earlier, between pen testers and developers, right? Like there's, can be an adversarial nature, which doesn't necessarily have to be, but like this definitely for me would take that adversarial relationship almost to nothing. I mean, it helps me be less adversarial and say, here's what I did, here's where the gaps I see based on what you said. And so like, for me, this helps make the conversation way easier. This greases it. That's a great way to think about it. This will grease the conversation.
I'm glad you said that, because that's actually kind of the whole point of my talk is like the way to fix the gulf between development and security, the way to really do DevSecOps is to bring those two groups together so that testing quality is testing security. It's the same thing. Mm-hmm. We can use tools like this to make them the same. And we found great response from developers when they see this, like when we show them, hey, here's all the routes in your application. Here's the whole attack surface, but you're not testing a whole bunch of it. They're like, oh, wow, well, we should be. I'll write some test cases to cover that. And like you drive the security test coverage up simply by influencing the developers to increase their test coverage.
Yeah, that's exactly what I see in this right here. That's, again, like I said, it's pretty sexy. So that makes my job easier, and it makes the amount of beer I have to buy them when I make their day miserable a lot less.
Fantastic. Well, so you're starting to get the sense of how easy this is. Anybody can write these sensors. Anybody can run an application and just browse through it, like, just a bull in a china shop, just clicking on stuff and filling out forms. That's sort of the advantage of this approach. The last thing I added to Jot was the ability to generate these charts. These are like simple graph viz charts, but you can put sensors on a bunch of methods. Anything you're interested in. Like in this case, I put them on, the routes, the parameter. Anytime you read a parameter, unsafe queries, encryption, expression language, and then you just use the application and Jot will create these pictures for you. And it's just kind of cool. Imagine you're doing a pen test and you're looking for SQL injection or expression language injection. Like, wow, that's a lot easier than just kind of doing it blind and hoping to see exception in the response that says, like you broke the query. This is really, I think, a cool way to understand security. And here's a couple other examples. This is an expression language example one. You can see here we got a header, then another header, then we get a parameter where the value of the parameter is midwinter, and then here is an expression that uses that term midwinter. So if I'm a pen tester, I'm going right there. I'm going to change this parameter input and focus on trying to exploit expression language injection there. One other thing that's kind of cool is you can reveal hidden parameters this way. Like if you put a sensor on the get parameter call, maybe there's parameters that this application is using that just aren't visible in the UI. You have no idea they're there. They're often there for debug purposes. They're kind of like secret parameters or feature flags in applications. You can find stuff like that using instrumentation this way really easily. And here's a cool one. This is a command injection. I actually didn't know under the hood, under runtime.exec, there's a socket connection that goes through, creating a whole bunch of different ciphers. So this is like visibility into the platform and what's going on underneath the custom code. There's a bunch of security relevant stuff going on. And it's just, for me, it's like really interesting to see that and understand what's going on there. Let's do another couple cool examples. So one thing that really frustrates me is the way that we communicate with developers as security folks. What's the most common way of communicating with developers? PDF report. It's like the worst possible option. And a 300-page PDF report full of false positives that somebody has to go through and figure out which is right, which is false positive, and then turn those into tickets and get them into a backlog and get them scheduled and get them fixed. No wonder it's not working. We also see a little bit better as things like, dashboards, putting these vulnerabilities into tickets automatically, things like that, maybe even into Slack. But there's a better way to communicate with developers, which is a failed test case. One of their normal test cases just fails. So here's an example of that. We've got a simple jot that says, hey, we don't want any command injection in our application, so we're banning the use of native processes. And in Java, you can do that pretty easily. It's one method underneath all of it called process builder. So we'll put a sensor in that. If we ever see that, the use of process builder inside a test case, so you can see we've scoped this method to this is like the JUnit master test case. And inside that, if we see a process builder call, we'll throw an exception and we'll give them this message. We can put whatever we want in this message to guide developers to do the right thing. So here it says, hey, our security standard, blah, blah, restricts the use of operating system commands from within web apps. Please find a safer way to do this and contact this for help. That's a really helpful message in a test case. And you can see now when I run my test suite, this is a normal test case that just runs, and somewhere inside the code, could be in a library that they're using, in some part of the app, someone tried to create a native command. So we're going to throw an exception. We're going to give them a full stack trace, and we're going to tell them what to do. So I wrote an article about this. There's an awful lot you can do, but what a cool way to communicate with developers. What a cool way to turn your security policies into code, into guardrails that automatically run as part of the development process. They can fix this, check in clean code, and move on. Any thoughts about that? All right, we'll keep moving here. There's a few more cool things I want to show. I love this one. I'm going to demonstrate this one. So expression language injection is really a dangerous vulnerability. It's the cause of the Equifax breach a few years ago. And it was just in the news as part of the Atlassian Confluence product. They had a serious expression language injection problem in their app, so that an unauthenticated user could completely take over the app server. Here's how that works. So expression language is a very commonly used way that developers access data and put it into a UI. So it's like a way of easily taking data out of some methods and pulling it in some beans or data structures and pulling it into their user interface. And so here's an example of just a field. Just using the application, I don't know that this data is being evaluated as an expression. So they're kind of invisible. In a lot of cases, they just, if you don't put in an expression in there, it just won't work. If I put in an expression, this doesn't get evaluated because it's just data. But if I use exactly the right syntax, something like $brace 1+1, now that expression gets evaluated. See, I'm getting a 2 back. That means I'm getting the computer to run a little bit of functionality on my behalf. And if you're a hacker, your spider sense starts tingling like crazy because this is the doorway to serious vulnerabilities. Now, I could do something like call a method here, like math.random. How about math.max? 1,12. And you'll see here, oops, put that in wrong.
There's beauty in error messages too, so.
Oh my gosh. So here we go. 1 plus math dot max. That should work. Okay, I must have mistyped it before. So you can see we're obviously getting 6 out of here because we're actually calling a method. And that's exactly what the Equifax hackers did and the Confluence hackers did. They did something roughly like this. They used a little more window dressing, but basically they did something like runtime.get runtime.exec open-a calculator. Right, so if this works, this should start a native calculator on this. And I'll copy this so I have this in my buffer. So this should work because right now I'm not running a job that does anything about this. So look, I was able to completely take over my laptop here, or in a real attack, this would be completely taking over a server in someone's cloud or data center somewhere. So what do we do about that? Well, we can use instrumentation to stop this. And let me show you another jot. This is a little jot. We're going to do the same routes thing we did before. The sandbox here is what's interesting, is we are going to instrument inside process builder.init. That's the constructor. And if we ever see that happen while we're inside an expression language evaluation, we're going to throw this exception. A little like the test case we did before, but this time it's only for attacks. So let's run this and I'll show you how this actually pans out. We'll start the application normally here, and we'll go back. And so the first thing is we want to check that this works normally. Just put in Jeff. And you can see, okay, so application's working fine. We can put in a simple expression here, like 1 + 1. And there's no attack in there, right? We're not calling runtime.exec or anything, but we are evaluating this expression. So this is, we didn't break the application by preventing this from running. But if I try to put in that same dangerous expression, now Jot will intervene and prevent that vulnerability from being exploited. So we sandbox the expression language engine to make sure that it can't do anything bad. We essentially put a wall around that so that it can only be used for harmless expressions, not for dangerous ones. And you can see here, you get the full stack trace here, so you can actually see, like, look, here's the expression call. This is the, from my JSP, el.jsp, you can see it called expression language engine. And that went through a whole bunch of stuff, and eventually it called runtime.exec, which under the covers calls process builder. And we, then Jot, which is this is Jot code, threw the exception and stopped it. And we get this detailed error message that says, hey, we got an attack, do something. So I think that's really cool. That's a super powerful capability. All right, I got a couple slides to wrap up here. I'll try and get through this quick. The two technologies that we just looked at have names in the market. The first one is called IAST, and all that means, interactive application security testing, all that means is you're using instrumentation to detect vulnerabilities. With Jot, we just built an IAST tool, our own custom IAST tool, and we detected vulnerabilities like SQL injection, and you can detect a whole ton of stuff. There's a bunch of sensors already built into Jot, like sample Jot files that you can use to detect all kinds of stuff. Rasp is what you use in production. All Rasp means, runtime application self-protection, all that means is you're using instrumentation to detect attacks and prevent exploits. And we just did that with the expression language injection. So use it in production. I don't know why everyone is not using Rasp. It is really fast, really safe. It won't break applications. And it's really, I wouldn't deploy an application on the internet without Rasp there to tell me who's attacking and to give me some basic protection against these fundamental vulnerabilities.
So what tool, let me ask this. So Rasp being the construct, what is who uses Rasp to do? All right, if I as a company am going to purchase a product that uses Rasp, Whom is someone that would use something like that, right?
You mean who owns the tool in the organization?
Yes.
Yeah, there's really, sometimes operations buys it and they build it into their platforms. So you can just say, you can add a Rasp component to your standard server stack
Okay.
and just harden up your stack. They could, you can put it into various environments. It's agnostic to things like containers and elastic environments and cloud. It's really part of the app.
Okay.
And so sometimes it's operations, other times it's development teams can choose to do this themselves. They can grab a Rasp library, build it into their application, deploy it, and now they're taking responsibility for security. They can get data about who's attacking and where the attackers are focusing. So that's the kind of the change from the old kind of, well, I don't know, I think there's a WAF somewhere
Sure.
approach.
Sure. Yes. Spray and pray kind of thing. I got you. Yeah.
Exactly. Yeah, that's a good question.
No, thank you.
So here's the big picture. We can move away from this sort of legacy scan and firewall model, which has a ton of problems that everyone is complaining about. Slow, inaccurate, slowing development, point in time, a bunch of different tools, requires experts, all that stuff. You can move to this embedded model that is really, it works in the background. It doesn't require a lot of expertise. It empowers all development teams to do their own security. In fact, a lot of organizations that I'm working with are using this. And when you get comfortable with it, you're like, well, my pipeline is testing security really well. I can push code through that right into production without having to wait. So it's really a different approach. And I just want you to imagine, instead of thinking about one application at a time, think if you have hundreds or thousands of applications. And instead of having to scan them one by one over and over, like painting the Golden Gate Bridge, instead, imagine they're all just instrumented. They've all got an IAST and a Rasp built into them, and they're all just continuously sending you telemetry in parallel about what's going on inside and alerting you to any problems. We instrument everything that's complicated in this world. Factories are instrumented for everything: smoke, vibration, temperature, noise, everything. And they've all got these sensors. They all come into a central console that monitors everything and alerts people if there's a problem in any of the machines. If there's a vibration, you get an alert before it's a problem. So this is the model. This is how instrumentation changes the way that we do AppSec. And ultimately, it allows you to push code into production faster, which is really what everybody wants, right? We all want to make cool things and then provide value to customers. We're relying on this code. I feel really passionate about this. All of you probably bank online. You're probably using healthcare and insurance and government services, and you're defended by the military. It's all software. We're depending on this software, and we've got to get better at making sure that we're not just finding and fixing vulnerabilities over and over again, like mowing the grass. We need to prevent these vulnerabilities from existing in the first place, and that's what IAST and Rasp can do here. So I've seen that it works. This is across tons of large enterprises. This red line is for SAST. It says the time to fix vulnerabilities on average for SAST is like 121 days on average, and you get to 71% in a year. IAST is leading to some dramatically better results. The median closed in 7 days across all of our customers, not the high performing DevOps ones, but all of them, and getting to 90% by the end of the year. And our top performing customers that have worked off their backlog and they're really like secure most of the time, they're closing vulnerabilities in 1 day and getting to 95% closed in a year. I'm really proud of these numbers. This is a total sea change in the way that application security can be done inside organizations. Any questions on that?
No, that 90 to 95 is so 71 to 90 is massive, and that 5% right there is the difference between an Equifax or a Target breach versus you not winding up in the news right there. That's what that 5% is right there.
Well, it's really the 71% to 95% is the big gap that I'm talking about, because most organizations are relying on static for this process for the most part.
Mhm.
And we can do better. This area under the curve, like all the area under this red line, is like window of opportunity for attackers.
Sure,
Yeah.
absolutely.
So look, I'll close with a couple articles that if you're interested in AppSec, I think these can help you. I spent, 15 years as a consultant and as an owner of a consultancy. We spent a lot of time figuring out how to communicate with development teams without breaking that trust relationship, building credibility and building bonds between security and development. And I wrote up how to do it. Like, this is an article about how to communicate security with the people that matter. So I just did a podcast on DevSlop about this, which I think is really useful. But this is a really undervalued skill. It's incredibly important to be able, you could be the best security researcher in the world, but if you can't explain what you did to people, it just doesn't matter. You might as well just go over in the corner and sit with your vulnerability alert. So this is a way of doing it. And I focus on what I call the 5-minute finding. You can write up a vulnerability in 5 minutes and do a great job if you follow the formula in this article. The other article I wanted to mention is this one called Making Security in a Software Factory, which is about how we transform application security from a separate silo into a fundamental part of the software factory. It's built into the machinery in the software factory, doing its job as just a normal part of building software. And it's a little bit, I'd say, controversial, but I think it's the future. So take a look and let me know what you think. You can connect with me on LinkedIn. I'd love to hear from you. And I'm happy to communicate about anything AppSec related.
Well, Jeff, thank you very much for that. I do actually have one question. So, and this is more of just a personal thing. Where'd you get Planet Level from?
It's funny, that goes all the way back to the .com boom. I was thinking about starting a startup. I was in law school at the time, and I don't know, it was a crazy time. In between like 1996 and 2000, I was working all day at an internet company, going to law school at night, and then I had this idea for a startup. And